Okay, we're going to look at parametric equations. Parametric equations are when x and y are described in terms of a third variable known as a parameter. So it's usually t or theta. So here's an example of parametric equations. So x is equal to t squared and y is equal to 3t plus 1. So normally we are used to seeing what's called Cartesian equations. So a Cartesian equation would be like of a form y is equal to x squared plus 5 would be a Cartesian equation. So if you have a parametric equation like this, you can convert it back into a Cartesian equation. We're going to look at how we do that with this particular example now. Okay, so I'm going to write my two equations. These are my two parametric equations. X equals t squared and y is equal to 3t plus 1. Now what you want to do here is to rearrange one of the equations so that t is a subject. Now it's generally easier to use a linear equation to do this, so I'm just going to say rearrange my y equals 3t minus 1, so y minus 1 is equal to 3t. Then t is equal to y minus 1 all divided by 3. And then what we want to do is substitute that into the x equation. That means x, everywhere you see your t, you're going to replace it with y minus 1 all over 3. So if we do that, you're going to get x is equal to y minus 1, which is going to leave it the gap in the top line, squared. And the 3 squared on the bottom line becomes 9, which is the same as 9x is equal to y minus 1 all squared. Now you could go on and multiply that out, but that's probably a more useful version of the equation. Okay, we're going to look at an unusual example here. This is where you're sketching the curves using the parametric form. So in this example it says sketch a following curve for minus 3 is less than or equal to t is less than or equal to 3. And the two parametric equations are x is equal to t squared minus 1 and y is equal to t squared, 2t. So what we're going to do first of all is a table of values. So you have t going from minus 3 all the way up to positive 3, and we want to find the corresponding x and y values. So we've done some of these for you already. We're just going to work through how we get the rest of them. Okay, so in this one, you've got to find the x value when t is equal to minus 1. So minus 1 squared gives you 1, then take away 1, that's going to give you 0. Let's put a 0 in here. Same idea for this one, when t equals 1, 1 squared gives you 1, take away 1 gives you 0. And that's all we have to fill in on this. So just have a look at a couple of these. Look at the first two, how they got them. So this was when t was equal to minus 3. Minus 3 squared was 9, take away 1 gives you 8. T is equal to minus 2. Minus 2 squared is 4, take away 1 gives you 3. Okay, the next line is our y. Next row is our y row. So when t is equal to minus 3, 2 times minus 3 is minus 6. When t is equal to minus 1, 2 times minus 1 is minus 2. When t is equal to 2, 2 times 2 gives you 4. So when we draw our graph, we're actually looking at these pairs of things. So that's our coordinate. We've got an x value and a corresponding y value. So when x equals 8, y is equal to, if I could squeeze this onto this page, x equals 8, y is equal to minus 6. So we'll mark that point on. When x equals, the next one was when x equals 3, y is equal to minus 4. The next one is when x is equal to 0, y is equal to minus 2. And then when x is equal to minus 1, y is equal to 0. And you'll see a pattern here, hopefully. When x is equal to 0, y is equal to 2. So back here. And when x is equal to 3, y is equal to 4. And when x is equal to 8, y is equal to 6. So where are we here? There we are. Okay, right, bear with me a second. I'm going to try and draw this graph. Right, I have a very dodgy looking graph for this. I've drawn this as best as I can here. But you can see it goes through, it's a curve and it goes through. So this point and this point, it's symmetrical. They're symmetrical about the x-axis. This is actually called a parabola. So we're going to look at this. We're going to find this in the equation in Cartesian form and see how we get on, just so we can see what the actual equation of this curve would be in xy form, in Cartesian form. Okay, so to do this, all I'm going to do is say my x is equal to t squared minus 1, my y is equal to 2t, and I'm going to use my y to say that therefore t is equal to y divided by 2. So therefore my x is equal to y over 2, and that's all being squared, minus 1. So what I've done there is where I see my t in my x equation, I replace it with y over 2. We'll just go on with that and see what we will get. We're going to get y squared over 4 minus 1, which means x plus 1 is equal to y squared over 4. And your last line, and that's going to be y squared is equal to 4x plus 4. And that is the Cartesian equation of this particular curve. Okay, in this next example, what we're going to do, we've got one where it involves theta. So theta, generally we'll use theta whenever there's a trig function involved. So here we're going to just do put all these theta values, make sure your calculator is in radians, and put all these theta values in for the x. So you should be able to do that. So 4 times cos of 0 is just going to be 4. 4 times cos of pi over 3 is going to work out to be 2. 4 times cos of pi over 2 is going to be 0. 4 times cos of pi is going to be minus 4. And 4 times cos of 4 pi over 3 is going to be minus 4. 4 times cos of 3 pi over 2 is going to be 0. And 4 times cos of 2 pi is going to be 4. Now the same for the y's. 4 times sine of 0 is going to be 0. 4 times sine of pi over 3 is going to be 2 root 3, and that's not a nice number obviously, so we're going to write that as 3.16. I think we're going to check that. 2 times root 3. 2 times root 3 is equal to 3.46, I should say, 3.46. And this next one is going to be 4 times sine of pi over 2, which is going to be 4. The next one, I'm just going to rattle through these, that's going to be 0. The next one is going to be the same as the first one. Is going to be, or earlier one's minus 2 root 3, so minus 3.46, and then minus 4 and 0. So we've got all of our ordinates, our x ordinates, and the corresponding y ordinates. Okay, we're now going to go through and plot these points. So I will do this for you, and we'll come back to just to show you how we're doing it. I'll just do a couple of these. We've got 4, 0. So when x equals 4, y equals 0. So when x equals 4, y equals 0 is going to be here. And the next one, when x equals 2, y equals 3.46. So very roughly that's where it's going to be. And so on. When x equals 0, y equals 4. So this one's going to be here. And when x equals minus 4, y equals 0. And so on. So I'll just finish off the rest of them and put it on the screen so we can see it all. Okay, there we have a few of the points. Now we didn't do all of the points on this thing, remember, but we've done a few, and you can see what is happening. It's going to have this general shape. It's going to actually be a circle. So I'm just going to draw that circle nicely, hopefully, and then we will have a look more into what these equations are actually doing. Okay, I've cheated a wee bit here so I can do a decent circle on this thing. So you can see what happens here. It goes through the minus 4, goes through the 4, minus 4 here, goes through the 4, and goes through the 4. So what we've actually created is a circle with a radius 4 and the center, the origin. So we're going to look at why that is. So we will see this again in your notes later on, but we're going to look at this stage why we have it. So just say, so we have x is equal to 4 cos theta, y is equal to 4 sine theta, is the parametric equation of a circle, center, the origin, and radius 4. Okay, that hasn't shown why that is the case. Right, so here we had x is equal to 4 cos theta, y is equal to 4 sine theta. Now this is a wee trick that you would need to be shown. You're not going to just guess this. In an equation like this, rearrange to make cos theta the subject. So you're going to get x over 4, and also make Also make your sine theta the subject. So sine theta is equal to y over 4. Now you're going to use your equation, your wee identity that says cos squared plus sine squared is equal to 1. So in this case, that means x over 4 all squared plus y over 4 all squared is equal to 1. And then we could go on and get that into continue getting that into Cartesian equation. Square the top line, you're going to get x squared. Square the bottom line, you're going to get 16. And again, square the top line, you're going to get y squared. Square the bottom line, you're going to get 16. So multiply across by the 16. So you get x squared plus y squared equals 16. Now you should remember from your basic work on circles from last year, this is a circle, center of the origin and radius 4. So you can see it does actually work. Okay, it says find the Cartesian equation for the curve defined parametrically as x is equal to sec theta and y is equal to tan theta. Okay, not too sure how I'm going to do this one. I'm going to see if there's a wee identity that links sec theta and tan theta. So I'm just going to write down my most basic one. Sine squared theta plus cos squared theta equals 1. And then what we're going to do is we're going to divide through by cos squared theta and see what you get. Sine squared divided by cos squared is tan squared. Cos squared divided by cos squared is 1. And 1 divided by cos squared is sec squared theta. Okay, so now we're good to go, because tan squared, we don't know what tan squared is, but we know tan is equal to y. So this is just going to be tan squared is just going to be y squared. 1 is just 1. And sec squared we don't know, but we do know sec is x. So it's going to be x squared. So y squared plus 1 equals x squared. Okay, we're going to keep going in this video, but you are ready at this stage to do parametric equations, exercise 1. So it's just after the previous chapter, which was on trig. So you'll get parametric equations, exercise 1. Okay, this is just a bit about the parametric equation of a circle again. So the equation of a circle can also be described parametrically. Consider a circle with radius a and center at the origin. The parametric equations are x equals a cos t and y equals a sin t. The parameter t, normally by the way folks in this they use theta for this, the parameter t is restricted to the range 0 is less than or equal to t is less than or equal to 2 pi. If it wasn't, by the way, so if it went on, all you would do, you just keep going around and round and round. So it's just not the 2 pi because 2 pi gives you a full revolution, a full turn. So the parameter t is restricted to the range not as less than or equal to t is less than or equal to 2 pi, so that there are values of t corresponding to each point xy on the curve and vice versa. It says in this example, derive the Cartesian form from the parametric equation x equals a cos t and y equals a sin t. So the idea here is to make cos the subject and to make sine the subject. So cos t would be x over a and sine t would be y over a. And then what you want to do is write down your identity. Cos squared t plus sine squared t is equal to 1. So in this case, that's x over a. That's what my cos was. So that's squared. And y over a, that's what my sine was. That's squared. So that's going to be x squared over a squared plus y squared over a squared is equal to 1, which means x squared plus y squared is equal to a squared. So you can clearly see this would be, again from your notes from last year, this would be an equation of a circle, center of the origin, and radius. This is your r squared, so r is just going to be equal to a. So center of the origin and radius a. Okay, this example says a circle is given by the equation x equals a plus 2a cos theta, y is equal to 2a sin theta, where a is positive and theta goes between 0 and 2 pi. It says find the center and the radius of the circle. So again, the idea here is to make cos theta the subject and to make sin theta the subject. So to make cos the subject, you're going to have x minus a all over 2a, and to make sin theta the subject, you're going to have y over 2a. And then again, all you're doing is writing down cos squared theta plus sine squared theta is equal to 1. So in this case, that's going to be x minus a all over 2a, and that's all squared, plus plus y over 2a, and that's all squared is equal to 1. Okay, if you do that out, you're going to get x minus a all squared, all over square the bottom line, you're going to get 4a squared plus y squared all over 4a squared is equal to 1. And then if you multiply through, you're going to get x minus a all squared plus y squared is equal to 4a squared. Now, you may have forgotten, but if you had x minus a all squared plus y minus b all squared is equal to r squared, we'll just say note, in case you've forgotten this is from last year, x minus a, x minus a all squared plus y minus b all squared equals r squared, is a circle with center AB and radius equal to r. Okay, so we'll just say, make a note of that, just say, therefore, x minus a all squared plus y squared is equal to 4a squared, has center, in this case, it's going to be a0, and radius is going to be the square root of 4a squared, which is just going to be equal to 2a. Alright, you are now ready to do the last exercise. There's another wee question for you to do with a solution there as well, but you're ready to do the parametric equations. And I think it's just exercise 2.